We look at 2.6 intersection of a line and a curve. When consider the intersection of straight line and a parabola, there are three possible situations. So if we have a quadratic curve, so this is a quadratic curve, so the shape we call it parabola. So if we have a straight line, maybe the straight line is look like this. So the straight line can be no intersection with the curve, or it have one intersection. So one intersection, we also call it tangent. And then we can have two intersections. Okay, so for the notes here, it said that we have situation number 1, 2 point of intersection, situation 2, 1.30 intersection. So the line cut the curve at two distinct points. The line touched the curve at the point. This means that the line is a tangent to the curve. So when you look at the question, it said that it is a tangent. Okay, tangent. Then that means they have one point of intersection. Okay, it have a spatial name for tangent. Okay, so one point of intersection is tangent. So the line does not have intersection. Okay, so this one is something similar to the 2.5 part. Okay, this is 2.6 ma. Something similar with the 2.5. We look at the b square minus 4ac, not equal, it's b square minus 4ac. Okay, that is the natural of root. So we have greater than 0, then two real and distinct root, and then line and curve is two distinct point of intersection. Equal, then two real and equal, then is one point of intersection, also tangent. T-A-N-G-E-N-T, tangent. Less than 0, then 0 real root, no point of intersection. So the condition for quadratic equation to have real root is greater than or equal to 0. So like what I summarized yesterday, so we have something like this. Okay, we have the we have the b square minus 4ac here. So we have the b square minus 4ac. We have three conditions. Okay, so the three condition here is we have greater than 0, equal to 0, or less than 0. So we have equal to 0, greater than 0, or less than 0. So for greater than 0, then this is 2 real and distinct. This one is 2 real and equal. And this is no real root. Okay. If we have a graph, then it will be something like this, or something like this. Like this also can, straight line like this. Then if we have a graph like this, then we touch one point. Also, we have touch one point. No real root, then they don't have intersection. Okay, they don't have intersection. Okay, so for these two, we combine. We have greater than or equal to 0. This one we say has real roots. Okay, has real root. Okay, so you must remember lah. Okay, this one we also call it tangent. Okay, equal to 0, tangent. These three case. Look at the question. The question say no intersection, less than 0. Two intersection, greater than 0. Tangent, or one intersection, then equal to 0. So we look at example number 10. Find the value of k for which y equal to 2x plus k is a tangent to the curve. So tangent, like what I said before, okay, tangent, they touch at one point only. Okay, touch at one point, then the b square minus 4ac is equal to 0. So this is equation 1, this is equation 2. Then we sub equation 2 into equation 1. Then we have the x squared minus 4x plus 4 equal to 2x plus k. Then we have the x squared minus 6x plus 4 minus k equal to 0. So we have the b squared minus 4ac equal to 0. Then a is 1, b is negative 6, c is 4 minus k. So the b squared minus 4ac equal to 0. So we have the minus 6 squared minus 4 1, 4 minus k equal to 0. 36, move to the other side. So we have 36 equal to 4 times 4 minus k. So both sides divide by 4, then we have the 9. Then we have the 9 equal to 4 minus k. Then we have the k equal to 4 minus 9, that is k equal to negative 5. Okay. If we want to check the answer, okay, for the value of k that we find, okay, first we have the y equal to x squared, okay, y equal to x squared minus 4x plus 4, and we have the y equal to 2x plus k. So let's say I have the plus k here lah. So I have a constant here. Then you can observe, okay, the k is 1, then they intersect at 2 points. Okay, then the value of k, when it go to negative 5, so we have k equal to negative 5. They intersect at 1 point only, one intersection point only. Okay, if the k is less than negative 5, then they don't have intersection. Okay, so you can see that the y equal to ax squared minus 4x minus plus 4 is look like this, and then the y equal to 2x plus k is something like this. When the k that we have is negative 5, then they have one intersection only. This is the intersection, so they have one intersection only. Okay, so this one we want to check, then the answer will look like this. Okay, so it's something like this. Okay, example 11, find the range of value of k which y equal to x minus 5 intersect the curve y equal to kx squared minus 6 at two distinct points. So we have two distinct points here, so that means they intersect at two different points. So two different points, b squared minus 4ac greater than 0. Okay, so greater than 0. So we have the equation 1 and then equation 2. Then we sub the equation 2 into the equation 1. So the y is kx squared minus 6. So we have the kx squared minus 6 equal to x minus 5. So we have the kx squared minus x and then minus 1 equal to 0. So when we move this, then minus 1. Minus 6 plus 5, then is minus 1. So for this case, we know that the A is k, B is negative 1, C is negative 1. So we have the b squared minus 4ac greater than 0. Then we have the negative 1 squared minus 4k negative 1 greater than 0. Then we have the 1 plus 4k greater than 0. Then we have the 4k greater than 1, k greater than 1 over 4. Okay, so normally, you observe, normally when the question want you to find two distinct points and no real root, they ask you to find the range. Okay, because we have the greater than less than, that is the range. Okay, so for the previous question here, when they have tangent or intersection of 1 point, then they will ask you to find the value of k, and you can get the exact value of the k. Okay, so we can look at this example. Okay, kx squared minus 6. So we have the kx squared minus 6, and then we have the y equal to x minus 5. So we have the y equal to x minus 5 here. So the k, okay, we look at this one. So the k is negative 5 here, they don't intersect. Whoa. Whoa. Okay. Mm, so they intersect at 2 points. We can look at this one. Uh, they intersect at 2 points. Okay. When the value of x, oh, k equal to 0 cannot. Okay. Just now we have the k equal to what? This one is greater than 1 over 4. Okay, greater than 1 over 4 not included 0. Okay, because the k cannot be 0. So we must know that the k cannot be 0. Because k equal to 0, then it will become a straight line. Then it become y minus 6, then it is a straight line. Okay, so we can see that when the k is negative, then they don't intersect. Okay, so 1 over 4 is 0.25 ma. So 0. 1 over 4. 1 over 4. 1 over 4. The answer is negative 1 over 4. Greater than negative 1 over 4. Negative 1, negative 1 over 4. Okay. So we negative 1 over 4. So just now we have the negative 0.1, then we have two intersection. Okay, negative 0.5, negative 0.3, then they don't have intersection. Okay, greater than 1 over 4, then we have two intersection. Okay, but the answer provided in the textbook is k greater than negative 1 over 4 is not very correct because from the graph that we see, the k cannot be 0. When k is 0, then they have one intersection only. So this one, just now the graph here, when we have a k equal to 0, then it become a straight line. Then they have one only. Mm. So, uh, so actually, if I didn't check with the graph using Desmos, I also will just leave the answer k equal to 1 over 4 lah. But since we check with the Desmos, then we know that, oh, so the k is greater than negative 1 over 4. At the same time, k cannot be 0. Okay. When k equal to 0, then we have one intersection. So k cannot be 0. Okay, and then if we have the k equal to let's say negative 1, or we have the just now negative 0.3 or negative 0.5 lah. Okay, so they have no intersection also. Okay, because the question want to have two intersection ma. Okay, tangent. I cut at a different page, a wrong page already. So 2 point two distinct point So this one uh no intersection. Okay, this is no intersection. And then just now when we have the equal to this, then we have one intersection. Okay, and if we have the this one two intersection, so if we have something like this, okay, if we have the k equal to 0, then they have one intersection only. Okay, and if we have the k uh, greater than this one, okay, so we have something like this. Now we will look like this. Okay. Mm. Okay. So this one we have k equal to negative 0.1 greater than negative 1 over 4. So two real and distinct root. So k equal to negative 0.1 less than negative 1 over 4. No real root. Okay. No intersection. So k equal to 0. Then it will become this one become y equal to negative 6. Okay, not quadratic. Okay, then they have one intersection. Okay, So we have the k equal to 0.5 greater than negative 1 over 4. So this one they have 1, 2, 2 intersection. Okay, so work example 12, find the value of k for y equal to kx minus 3. Does not intersect this one. So does not intersect. So we have the b square minus 4ac, okay, less than 0. So this is equation 1, this is equation 2. So we sub uh, 2 into 1. Okay, normally last time I sub 1 into 2, then we have the kx minus 3 equal to this one. Then I have to move to the x square side. So I will prefer sub 2 into 1. No? So we have the x square minus 2x plus 1 equal to kx minus 3. Then we have the x square minus 2x minus kx plus 4 equal to 0. Okay, because we have the plus k move become minus k. Negative 3 become plus 3. 1 plus 3 become 4. Okay, so the a here is 1. B is negative 2 minus k. C is 4. We have the b square minus 4ac less than 0. Then we have the minus 2 minus k square minus 4, 1, 4 less than 0. Then we have the 4 plus 4k plus k square minus 16 less than 0. Then we have the k square plus 4k minus 12 less than 0. Like what I said yesterday, we have the negative 2 minus k square. Okay, we can assume that it is 2 plus k square. Then 2 square 4, 2 times 2 times k, 4k meter, k square at the end, because we can make it factorize negative 1 and then 2 plus k, the whole thing square. Then it is negative 1 square, 2 plus k square, something like this. Okay, so this is this one, and then we actually get this one. Okay, so I open the bracket for this one. This is a quadratic inequality. So we have the k2 6 plus 4 minus 2. So the critical value is k equal to 2 and k equal to negative 6. So we have this negative 6 and 2 less than equal, less than is here. So the k is between negative 6 and 2. So this is in the section 2.4, the quadratic inequality. So we have the quadratic inequality. So 2.6 is sometimes the question is the combination of the 2.4 and the 2.5. So that is we have the b square minus 4ac greater than or less than something. And then some question they will give you linear, then it is easy lah, we get the range straight lah. But some the inequality that we get is a quadratic inequality. This is a quadratic inequality. Then we have something like this. Okay, so we still remember if less than, that is between the two value. Is greater than, then it is 大大小小 greater than the larger value, smaller than the smaller value lah. Okay,